everywhere. All right, so guys, make sure you label this algebra review day 1. We're going to be doing 4 days worth of this stuff. And it's really stuff that you're expected to know coming out of basically Algebra 1. And after having geometry, they still expect you to know it well. So I'm trying to get these so it's fresh. So next year, you don't quite hit the wall so hard when you start up in college algebra or algebra 2. I want you to do really well in there. So one of the things that you guys do, and we do it all the time in geometry, is we solve equations, right? And we know there's lots of different ways of solving equations. But one that a lot of people forget about is the method of when you have radicals in your equation. So something like this. Solve for, let's say this x, but we get 2x plus 5 minus 7 is equal to 4. Now, remember, what's the gist of solving any equation? Isn't it to find our unknown? Do the rules change just because things look funky? No, they don't. You have to be able to do the rules. I still need to isolate the variable. So here when I have the square root of 2x plus 5 minus 7 equals 4, what would you do first? What's the natural instinct if you're solving the equation first? What would you do, Alex? Yeah, you're gonna add 7 to both sides. So you're gonna get a 2x plus 5, all underneath your radical, equals 11. Now we're to the point where this radical is really cumbersome. I need to get rid of it. Well, remember the rules of solving equations. If you do it to one side, what do you have to do? Do it to the other side. Well, what would you do? Because that radical is a pain. What do I need to do? Yeah, you need to square both sides. So you're going to square it. And so when we get that, you're going to get a 2x plus 5 is equal to 121. Go ahead and finish solving. Now this part's the easy part. You're going to solve for it. So you get 2x is equal to 116. X is going to equal to 58. Now, a lot of times, you guys are used to doing this in algebra, and let's admit it, right? You get an answer, you move on to the next problem, right? Here's the problem. This is a type of problem you can't do that. Because there's some problems with that. Like, for instance, what if you plugged it back in and you get a negative underneath your radical? Can you have a negative underneath your radical sign? No. So you always, anytime you have a radical like this type problem with a square root in it, you always need to plug it back in and check it. Now, the nice thing is, do you have calculators to do that? Right? So remember, if an equation is true, it's going to equal the same thing on both sides. So when you do this one, always check. So I'm going to do that. I'm going to plug it in. So I get 2 times the square root of 58 plus 5 minus 7 is equal to 4. So when I get that, I get 121 minus 7 is equal to 4. Well, what's square root of 121? 11 minus 7. Oh, look, do I get 4 is equal to 4? So did it check? Yeah. Now, there's times it won't. So if you get out of the habit of checking it, it's going to be wrong. Kind of like the idea when we've been working with radicals, right? When we sit there and we solve for something, let's say something like the square root of, let's say, 35. How would you solve that problem? What would you do? What do I do to solve x squared equals 35? Square root of both sides. How many of you would just go here and tell me the answer is the square root of 35? Any of you say that's right or wrong?
Wrong.
Hopefully by now you think that's wrong. Why is it wrong? You have to check the plus or minus. Guys, you can't get rid of that until you saw it in context of a problem. In this case, you have to have both. Don't forget all those rules, and the reason why I've harped on them sometimes when it just like, in geometry, that shouldn't matter. It's because of trying to make sure that you still apply them when you get back into algebra world. So be very careful on those type of things. So simple type equations, I'm just throwing tons of equations at you for you to solve on tonight's homework because I want to see how you do it. I want you to struggle with it and make sure you ask me questions because we need to know where you land on it. All right, now another topic that we had, so let's just move on to another topic, is when we work with systems of equations. And remember, we had some of these on some homework, especially at the end of like second semester and the beginning of end of first semester and beginning of second semester. We worked a lot with systems of equations. Remember, when you're working with systems of equations, is you're going to have 2 equations, with two variables. Because if you have an equation like this, I get x minus 5y is equal to 15. You know you have an equation of a line, and you have an infinite set of points that work. Great. So if I really want to know what a variable is going to absolutely be, I really need another line to intersect it, so I know it. So a system of equation is going to have multiple variables in it. My oldest, is in college algebra right now. She just got done solving systems of equations for 4 equations with 4 variables. That's your next year future, any level, that you can be able to do that. So we need to make sure that we can take a simple 2 variable equations and do a systems of equations with it. So you got to remember off the top of your head, there's several different ways of doing this. Like one way of doing this was graphing. You graph your 2 lines where they intersect. That's your point of intersection. It's a valid way of doing it. The problem is if you don't graph well, it could go wrong, right? It could really go wrong. And then the second way that you did it was using the substitution method. That's when you take one of your equations, you isolate one of your variables, like solve either for x or y, then plug that value into the new equation. In fact, if you were from like China or South Korea or Indonesia or those places, that's the only method they actually use. They don't use any other method when they're solving for systems of equations. The problem is when you have fractions and stuff like that, it's really gross. It doesn't flow easily, if you want to think of it like that. So it's harder to do. So my favorite method, and the one that we're going to review real quick, is just your elimination method. That means I need to get rid of one of my variables. And so here's the cool part about elimination method is you pick which variable you want to get rid of. Sometimes the equations, you look at them and you're like, oh yeah, those two just go together, it's beautiful. But remember, the goal of elimination is you need coefficients in front of your variables that are exact opposites. So that way when you add the 2 equations together, they simplify to be the number 0. So guys, pick one. I don't care which one, x or y today. Yeah, x? All right. Now, if I'm looking at this and I have my 2 equations, which one of the 2 equations, the top one or the bottom one, would you change anything to? The top one. All right. What do I need? If I have a 2x, a positive 2x on the bottom, what do I need the top one to be?
Yes.
A negative 2x. How many of you had teachers last year do this? Just multiply everything by a negative 2. Did your teacher do it like that last year? Okay, can I change it a little bit so you don't get it wrong? Could you do it like this next time, please? Why do you think it should be done on both sides like that? Yeah, you will forget. Not every time, but you will actually get to the spot where you forget to do it. So if you put it with the 2 sets of parentheses like that, this is called a scalar. You're multiplying by a scalar is the fancy term they love to use. You just got to be very careful. So you rewrite the first equation when you distribute everything with a negative 2. So again, negative 2x plus 10y is equal to negative 30. Your bottom one is going to be 2x minus y is equal to 10. Now this is where the elimination happens. We add our 2 equations together now, and you go straight down. So I get a negative 20. Something got wrong here. That should be an 11. Did I write something? Oh, I wrote something wrong. I changed what I wrote on here. Oh well. Guys, I'm going to change this just so the numbers work out better. Is that okay with you guys? I'm just going to change that 10. Here. Thank you. Sorry. It was throwing me off. What do you get? 10y and y. What does that give you? 11y. Now solve for y. And you get negative 20 over 11. Now last year, if you would have gotten negative 20 over 11, you'd been like, I did something wrong. I've destroyed this equation. It is not right. Okay, hello, I've never done that with you. Anytime I've given you systems of equations, don't you normally end up with a fraction? That's more likely to happen than not. So, and before you panic and say, all right, I did something wrong, I got negative 20 over 11, how about trying it first? And then checking your answer at the end to see if you were logical or not. Because now, no matter what method you use, this process stays the same. I got to substitute in a negative 20 over 11 in for y. Now, which ones do you go to? Well, my advice is always go to one of the original equations. Don't go to any one of the ones that you've already manipulated or anything like that. It really doesn't help that much. So guys, which one of the two equations do you want to go with? An x minus 5y equals 15 or a 2x plus y is equal to 10? Which one do you want to do? You guys want to do the 2x plus y equals 10? Is that good? You guys really care? That's good, because I'm kind of the same way. All right, so just plug in. Let's do the 2x one then. So I get 2x plus y, which is a negative 20 over 11, equals 10. Now, what is the first thing I'm going to do? Someone said multiply by 11. Could do that. How about if I just move the 20 over 11 first, right? So I'm going to add it to both sides. So I get 2x is equal to 10 plus 20 over 11. Well, guys, that's going to be 110 plus 20. So that's really 130 over 11. What do I need to do both sides? Multiply. Someone said multiply by 1/2, or someone else said divide by 2. Is that the same thing? So I'm going to divide by 2. Can I go like this and kind of cheat and put it like that on the denominator? If I do that, 2 goes into 130 how many times? 65. So I get x is equal to 65 over 11. Now, here's the thing. Your ordered pair, it'd be 65 over 11, negative 20 over 11. How do I know if I'm right? What do you have to do? Check your answer. So guys, get out your calculators. You're going to want to check it. Which equation are you going to want to check it with? Nope. We use the bottom to solve for x. Guess what you want to use first? The top one. You want to use the one that you didn't substitute it into, do your final variable. So you want to go to the top one. So you're going to want to use your x minus 5y equals 15. So like literally, you're just going to sit there and go, okay, I got 65 over 11 minus 5 times a negative 20 over 11. Does that equal 15? Just put it in your calculator. You got the calculator with a fraction key on it. Do I get them 15 is equal to 15? It should. Basically, when I'm doing it in my head, I come up with 15 equals 15. If that's the case, are we right? So if you get a fraction, before you panic, finish it out and then decide if it works or not. So you do have a couple of systems of equation problems you have to do as well. So 2 new things that we've done. Now we're going to go back to something I've already taught you this year. But anytime I've reviewed it, you guys have kind of not failed, not remembered as well as I liked. And this is actually something a teacher who used to teach here 3 years ago, whose name is Miss Frizzy. She rocks. She's an awesome lady. She's getting her doctorate in math education and math, so she can be a college professor teaching math teachers how to teach math. She's a phenomenal math teacher. So this is the one thing she asked me when she was the college algebra teacher, that no matter what, I'd review with you, even though I already taught it to you in the fall. And guys, it's called equations of lines. Now, here's the part I'm not going to do. I am not going to sit there and work problems with you. If you really want me to see how problems are done again, literally go into the fall geometry class and look up in chapter 3 stuff. It's the equations of lines in chapter 3. It will be on there if you ever need a quick refresher or review. What I'm reviewing with you is how to graph them and what are the 3 forms. And then you're just going to practice, because that's the only way you're going to ever get these down, guys, is if you can do it on your own. So the number 1 form that you work with, in fact, we just applied in our systems of equations, is the standard form. All right, the standard form. Do you guys remember what that is? Yeah. You have to AX what? AX plus BY equals. A cereal, right? A cereal. See, wow. I am so tired. I was up a little bit late last night celebrating Steph's victory to get into state. I'm way past my bed. I'm like so tired. I was so wired last night. It was really fun. All right, so it was like, wow. Anyway, here's the rule though. What's A, B, and C must be what? Integers, okay, which is whole numbers and their opposites, so must be integers. So no fractions, no decimals, right? And just so that our class is on the same page, we say A must be what? Yeah, A must be positive. All right. Now, do we ever use this to write equations of lines? No, but we do use these to quickly graph, right? So something like 3x minus 2y equals a -6. That would be an example of standard form. Now, up above, that was our systems of equations before we started solving. They're both in standard form. We have the x on the left, the y on the right. Worked out great. But this one, we normally change to this form, or we change this form to like slope-intercept, right? So we use this form, but a lot of times we try to get rid of it if we can. But what's really nice about this form, it's actually really fast to graph. So when you think about it, to graph it, it's really easy. You guys remember the method?
Yeah, the cover up.
Yep, we're going to use what's called the cover-up method.
The Hillary.
The politician method. All right, so when you work with it, you need to remember you're going to find the x and y intercepts. And remember, intercepts are actually ordered pairs, so don't forget that it has to be ordered pairs. So using what we did before, we had 3x minus 2y is equal to 6. Oops, excuse me, -6. Get that the right way. I want to find the x-intercept. So if I have the x-intercept, this is going to be a long afternoon, I just realized. I'm going to teach 3 periods today. I'm going to help teach algebra 2. All right, with this one, which is 0 if I'm looking for an x-intercept, the x or the y? So if I have y is 0, which one do I cover up? The negative what? The -2y gets covered up. So then you have left 3x is equal to a -6. Well, what's x going to equal? Yeah, it's going to be a -2. There's your x-intercept. Now your y-intercept, x has to be 0. So what do I cover up? Do I cover up the 3x minus sign? No. No, what do you only cover up? 3x. So that way you have left a -2y equals a -6. Well, what's y going to be? 3. Now, how many points do you need to ever determine a line? 2, so graph it. Let's have a little bit of fun. So, all right, so when you do that, here's where it's nice, because you got your draw key on this. If you want that, you can move it over so it's right on a line. There you go. So, I don't like where it's at right now, though. Let's see if I can get it. No, now it's not going to move for me. Oh, well, I'm not going to worry about it. So, what do we have? Let's have our 2 points. -2, 0. That'll be like right here. What's going to be 0, 3? Isn't that going to be up here? There's your line. Very fast, very simple. Now, next year, don't be surprised if you get asked to use 3 points. Now, with a standard form, you're not going to do 2. You're just not going to use 3 points. But your other forms you can, because you can use the slope a second time. But how hard is that? Is that real hard, guys? No, not that bad. All right, now what form should be your go-to form? Yeah, hopefully I got you guys convinced that you're supposed to use point slope anytime you're in doubt. Anytime. All right, what's the point slope form? Y what? Yeah, y minus y1 equals
X minus X.
All right, so we got our slope times the quantity x minus x1. Now, here's an example of this, but let's make sure we know this. So m is slope, and x1, y1 is a point on line. So it's a point on the line. So let's make sure we have that. So if I have something like the following, y plus 3 is equal to a -1/3 times the quantity x, let's go minus 2. You should be able to pull out very important information so we can graph them a little bit. You should be able to pull out a point. What is the point? What point do you have? So it'd be 2 minus 3. So the point is going to be at 2 minus 3. And guys, what is our slope? It has to be -1/3. So when I graph this, It's actually really, really fast. It's just as fast as if I had it in slope-intercept form. Because what do you do first? You plot your point. So we plot the point, and then use the slope to get a second point. Now, let's use the ones here so we don't have to recreate a new example. So there we have our point and our slope. Let's have a little bit of fun and graph it real quick. Let's go here. Just love that. So much fun. All right. So our point is at 2, -3. So here's 2, -3. Guys, what does our slope tell us to do on that one? It's a -1/3. Okay, you have to respond. What does a -1/3 tell you to do? Down 1, right? From your point, you drop down 1, and then you run to the right. How many? And guys, remember, you should always run to your right. Drop up or down first, and then run to your right. You can consistently get it right. All right. Point slope should be your go-to. The only time any of these don't make sense is when you have a vertical line. So remember, vertical line, what's your slope? What's your slope of a vertical line, scholars? Undefined, right? So it's undefined. So remember, you just have to know how to do it. All right, last one. This is the form you all learned, and think when I asked you for an equation line, this is where you all instantly went to, right? Slope-intercept, which is what? What is it, guys? Very good. Y equals mx plus b, where m is my slope, and b is the y coordinate of the y-intercept. And remember, your y-intercept would be something like 0b. Intercepts are ordered pairs, not a single number like your textbook would try to prove it to you, or most math textbooks would try to prove it to you. So with that, let's have an example like this one, pretty straightforward. Let go y equals 3x minus 4. What is your slope, scholars? Some people say 3/1 because if they know they're going to graph, they want to remember to run right, right? And then your ordered pair is going to be 0 what? Yeah, 0, -4, because that's your y-intercept. If you know those two things, you're already ready to graph. Because really, the only difference between slope-intercept and point slope is my initial point. My initial point is always a y-intercept. So plot the y-intercept. Then use the slope to get the second point. Now, if you're in algebra, probably a third point as well. They'll just want you to continue one more time. But this is the one that a lot of people change to. Like, if I can change to this, I can graph it real easily. The whole point is don't take the time to change. A lot of times people mess up a little bit more. So let's graph it, and then we'll be done with notes. So let's put our graph on here.
Is it possible to put a plus or minus sign into a calculator?
Yeah.
No, like both of them. Plus.
At the same time? No, but some I know programs do. I know some do. All right, so let's work with this. So we have 0 equals -4, so that's going to be right here is my y-intercept. Then what does my slope tell me to do? Yeah, we're going to go up 3, so 1, 2, 3, over 1's our second point. And there's your line. Hopefully yours went through your points a little bit better than mine did. Guys, does this jar memories a little bit? Do you think I'm going to ask maybe a slope, like perpendicular bisector problem or something? Or I give you 2 points and you have to find a slope? Yeah, it sounds like you have to change. Yeah, exactly. All right, so here's what we got. The rest of the class, guess what I want you working on? Homework. So let's get it done.